we're good.
Stopwatch.
Okay, here we are again, Brendan, and this is getting old, so we want you back here. And here is the first thing we did without you, so join us. If we took the indefinite integral from -1 to 2, and everyone got 3/8, but then I boldly said it was not equal to 3/8. And we're explaining why that is. This is an improper integral in disguise. We'll call it a sneaky improper integral. Because a lot of times students, teachers, everyone will not notice that it is an improper integral. And when we look at the graph and the algebraic expression, we see x cannot equal 1. So on the graph there's an asymptote. So the area between -1 and 2, and the area between this graph and the x-axis has long areas as we go toward a positive and negative infinity on the y-axis. So therefore, we've got to set this up as an improper integral. So limit as b, we'll say approaches 0 from the left. Remember the notation? When 0 approaches, from the left is the little negative sign. So this, I'm on this side over here. So I'm okay with the -1, but I'm going to put a b here because we never quite get to this asymptote. So I'm going to take the limit as we approach that asymptote. That makes sense? Hopefully. So then it's what? I'll just write it as x to the -3. That's what that means. And then I'm going to add to it. I have to do this in 2 pieces because of I have to do this side and then this side. Write down what limit you think is going to appear over on this side. Don't use b. We'll use another. I'll use t this time. You can use whatever. We don't want to use x, and we don't want to use the variable name that you used here. So I started with b, and now I shifted to t. Got any ideas what this second integral might be in order to complete this whole integral that I'm looking for? What do you think?
Is it t on the bottom and then 2 on top?
And right, and as we approach what? What are we going to approach on this side, Aaron?
On infinity?
No, because this is where the discontinuity is. So,
would it be 0 from
right.
the right?
Yes,
Oh, okay,
exactly.
that's
0 from the right. All right. All right, now we're in familiar territory like yesterday. So we can just go ahead and start taking the integral and evaluating, putting in the b and the -1, and then taking the limit as x approaches 0 from these. But do you see why you need to split it up? Because there's a big asymptote right down the middle of this one. So this is improper. It does not come out to 3/8. Let's see what it does come out to be. All right. Why don't you work on it while I work on it? So what's the integral? 1 over -x squared when you put it in this form?
Yes.
Is that right?
I think so.
Okay. So I'm just
Wait,
going
would
to...
it be 1 over -2?
Yeah.
Squared?
Well, x to the -2 over -2. You're right. So there's a negative.
Nanny.
X to the -2 over -2. So the 2 is in the bottom, right? Correct? Now I got it? All right. Let's go ahead and keep... I usually do one integral all the way down and then I start the other one. If you want to go across and do them step by step, that's fine. All right, look what happened on my side. Right here, I'm ready to take the limit as b goes to 0. So I got right here a -1 over 0. And that's one of our determinant forms. And what is 1 over 0? Johnny, what's 1 over 0?
Is that infinity?
It is. So right away, in the middle of my problem, I have a divergent answer. So why? I don't even have to finish this side. So that's one of the reasons why I do one integral, because if it's divergent, I don't have to do the other one. So this diverges, which means the area that I described over here, the area between the graph and the x-axis between -1 and 2, so this area, all this area, and all this area does not approach a number. It just keeps getting infinitely larger. So it goes, as they say, it's increasing without bound. It has no value, so it diverges. So some of them will converge, so that one didn't. All right, let's try another one. I only have two more to show you. I think I'll just set them up, because you know how to do this part, don't you? I mean, it's nothing new on this. You okay? You feel comfortable with that? So I'll just set them up, and then on 2 more, and then I'll let you get some of your work done. All right, the next one, let's see if we can find one that comes out to be a number. How about this one? Maybe we should do this one out. Don't write too big. Alright, I'll have to write small now because I didn't leave myself much room. Let's look at this one. So is this going to be proper or improper? 0 to 1, that looks proper. But then when I get inside of here,
Oh no,
what happens?
improper.
And what happens again at this one? Where is the asymptote this time?
1 over x to the 1/3.
If you're asking yourself what values would cause this to be a mathematical impossibility. So what value?
0.
Right, so x equals 0 again is your asymptote. We'll do some that's not at x equals 0 as well. And so I'm only interested from 0 to 1. So this is improper, but it's a little simpler than this one. There's only one integral involved. Do you want to try to set it up? I'll say the limit as b approaches 0 from the right. See if you can figure out what's going to follow. And we're trying to go from 0 to 1, but we can't just start at 0 because it doesn't exist. It's an asymptote. So that's why it's improper. So we have to make an integral out of it. What do you think? Erin, what do you think this limit will be?
B to 1.
B to 1,
Oh,
right?
man.
From, and this is x to the what? Minus 1/3 dx. Go ahead. I said we wouldn't do it all the way out, but go ahead and do this one. I want because this I think this is one that converges. I'm trying to think what the graph looks like. Cube root of x, 1 over cube root of x. I think it has a spot here and a spot here, but we're only interested in this spot. See if this one converges or diverges. I'm not sure if I did it all the way out. So when we integrate x to the negative 1/3, x to the what, 2/3?
Mine converges.
Yay!
Oh yeah.
So we get the limit
Someone did the same.
as b approaches 0 from b to 1. So 3/2 b to the 2/3 minus 3/2. Oh no, it's 1.
Oh, I had it the other way
It's
around.
1, you're right. Minus, because b is on the bottom. Minus 3/2 b to the 2/3.
Wait, why is it 1?
We're going from 0 to 1, and 0 doesn't exist, so that's where we take the limit and put in our made-up variable b, or t, or whatever, m. And so now we got the limit. So we've got b on the bottom, 1 on the top. So we put in the 1 first and then the b. And the limit as b approaches 0. This, anything to the 0 to the 1 is 0.
I mean, I plugged 1 in there. 1 in for the x, and then I just got 3 halves minus 3 halves b to the 2/3.
Oh, yeah, this is 1. That's right. So there's no, and this part is just 1. You're right. So that's why you got it to converge. So 3 halves, and this now is b, this is the 0 one here. Alright.
Put this one in first.
Converging integral.
It's just
Exciting movie.
So then we put this in there, it's that. So then we put the 0 in.
Alright.
This completely zeroes out. So then it's 3 halves minus the 0.
Alright, how many minutes so we got up to?
Oh, it's 10.
Alright,
We're
alright.
like,
we need
Almost
to-
11.
Alright, that's fine, as long as we stay under 15, and that's well under. You can get us on the next part, okay.